Okay. Good morning, students. Welcome to the Real Analysis live lectures. So today we are going to discuss Bolzano-Weiestrass theorem. It is again an important theorem in real analysis. So before proving to this theorem, we will prove one lemma. Okay, or lemma or theorem, we can say. That theorem we can state it separately, or let me write the statement first. This is not Bolzano-Weiestrass theorem, but I am writing a theorem which will be useful while proving Bolzano-Weiestrass theorem. Okay. Every sequence of real numbers has a monotone subsequence. We have to prove every sequence of real numbers has a monotone subsequence. If you give me any sequence, I can give you a increasing or decreasing sequence. Monotone means either increasing or decreasing sequence that we want to prove. Is that okay statement?
Yes, ma'am.
Xn is arbitrary sequence. Then from that Xn I can extract either increasing or decreasing sequence. Any monotone sequence means it is a subsequence of that original sequence. Okay, so let proof. With this, let Xn be a sequence of real numbers. No, real numbers. Define a set S is equal to n belongs to set of natural numbers such that xn greater than xm whenever m less than n. Xn greater than xm whenever m less than n. Xn greater than xm for m, not m, okay, first we have written n, so n greater than m. We have defined a set S such that set of all natural numbers xn, set of all natural numbers such that xn greater than xm whenever m greater than n. Okay, or with, when instead of whenever we can say with m greater than n. I can write with m greater than n. Can I define such a sequence? For this, you can imagine, we will draw one, let me draw one diagram. Everyone know volcano? Volcano म्हणजे ज्वालामुखी.
Yes, ma'am.
So what is the motivation of such a defining set is, like, so you assume there is a volcano and if we want to see it, but whenever we want to see it, we have to make sure of safety also, no? We can't go closer of it to see it. I might have used shapes. Okay, drawing is not that much good, but you can assume this is volcano. You can assume this is volcano. We want to see it, and we want to see from the far. And if we want to see it, we will go to the height. We will select one building. Suppose this is x1. This is let me write numbers. First building, second building, third building. This is fourth, fifth, sixth, seventh, 8, 9, 10. Okay, I have drawn 10 buildings, but there are say infinitely many buildings because we are assuming sequence. Okay, and what xn denotes, it is a height. Okay, n denotes number of that building, number of that buil building, and xn denotes its height of the building. Okay, now which if you want to watch this volcano, which building you will prefer? Which number building you will prefer?
10th building.
10. Everybody will prefer 10. Everybody can't watch from 10, na?
Yes.
So suppose some people will select 10 number, then
Fifth one.
fifth one. Okay. Then
9.
9.
9.
Yes. It will be more safer. Yes. Then will you select 6 number? Will you select 6 number building?
No.
If you select from this, you can't watch that volcano because this one is bigger. Fifth one is bigger, right? Height wise, this is bigger. So 6, 7 also you won't select. 8 also you won't select. But you can select 9, 10 and so on. Or you can select this one also. First, second, third, right? But you won't select fourth one. Is that right?
Yes, ma'am.
No. So what this set, whatever set I have defined, this S, suppose I am having different number of buildings, infinite number of buildings with different heights, and now I am constructing a set with means n belongs to n such that xn is strictly greater than xm with m greater than n. म्हणजे कोणती बिल्डिंग सिलेक्ट करतोय आपण? सपोज इफ वी सिलेक्ट दिस वन, I am selecting this x1, whether 1 belongs to this S,
Yes, ma'am.
whether
Yes,
1 belongs to this set. So you have to check the condition x1 greater than, whenever m greater than n, height must be lesser. Are you getting this?
Yes, ma'am.
Yes. What about this 10 number? 10 number, त्याच्या अगोदरच्या सगळ्या इमारतींची हाईट कमी असली पाहिजे, राईट?
Yes, ma'am.
तेव्हाच तो एन ती बिल्डिंग म्हणजे तो नॅचरल नंबर ह्या एस मध्ये असेल. आर यू गेटिंग दिस?
Yes,
Yes,
ma'am.
ma'am.
सपोज दिस 5 पण येईल कारण त्याच्या अगोदरच्या ज्या बिल्डिंग आहे 1, 2, 3, 4 ऑल बिल्डिंग्स हॅव्हिंग लेस हाईट देन 5 number building. So which numbers it will contain? this S मध्ये कोणते कोणत्या बिल्डिंगचे नंबर येतील समजा? फ्रॉम दिस 1 will be there,
5, 9.
1 will be there, 2 will be there, 3 will be also there, 4 can't be a member of this. Okay, 5th will be there, 6, 7 also won't be there, 8 is also not there, then 9 and 10. Okay, so on, means because infinitely many buildings, but they should satisfy that condition. Is that, are you getting this set S?
Yes, ma'am.
So I can construct a means I can define a set S, and it will be always non-empty.
Yes, ma'am.
Why it will be non-empty? Why it will be non-empty?
So there will be at least one element.
Which element?
Uh,
First.
First one will be always there because there won't be any building before that first building, right?
Yes, ma'am.
Yes, ma'am.
Okay. So now, so we can define, if we are having any sequence of real numbers, we can define such a set S. Okay. So we have defined a set S. Then what can I say about that set? Either it will be finite or it will be infinite, right? Either it will be finite or it will be infinite. Then S may be finite or infinite. Suppose S is finite. Suppose S is finite. Okay. If S is finite, then there exists, suppose S is finite, then there exists n belongs to set of natural numbers such that n is greater than equal to S for all small s belongs to capital S. If it is finite, okay. If S is finite, then there exists a natural number n which will be biggest among all that natural numbers. Say it is capital N. Okay. Now, let small n1 belongs to n such that n1 is strictly greater than n. Then what can I say about n1? Whether it will belongs to S or does not belongs to S? What can I say about this n1?
does not belong to us.
Then n1 does not belongs to S, this set. Therefore, what can I say about xn1 and xn? Or okay, let me, okay, first element, this one. Okay, now choose n2 greater than n1, then or n2 greater than n1 there exist n2 greater than n1 with xn1 and xn2. What can I say between xn1 and xn2? Less than or greater than?
Xn1 will be greater.
n1 is less than n2, so xn1 will be greater than or less than?
Greater
Greater
than
than.
our set condition.
n1 and n2 does not belongs to S. n1 does not belongs to S. n2 also does not belongs to S. So what is my S?
Okay.
What is my
Less
S?
than.
It is n belongs to n such that xn greater than xn with n less than m with is it my
Yes,
this
ma'am.
S? So n1 does not belongs to this set means what? n2 does not belongs to this set. So n1 and n2 does not belongs to this set and it satisfies this n1 less than n2. Then this condition fails. xn1 should be less than xn2 then. Are you getting this?
Yes.
It will be less than. Are you getting this?
Yes, ma'am.
Ma'am, it's not following the set condition.
Ma'am,
Huh?
As it does.
Continuing in this way, we will get infinitely many natural numbers. We can have, continuing in this way, there exist natural numbers n1 less than n2 less than n3 and so on with what about xn1 xn2 xn3 and so on.
Less than.
Is that okay?
Yes, ma'am.
So what is this? This is a increasing sequence.
Yes, ma'am.
Yes, ma'am.
This implies xnk is an increasing subsequence. Okay, this is from where we have extracted this. This is this from our original sequence xn. Okay, so xnk is an increasing subsequence of xn. So which is a monotone. So xnk is a monotone subsequence. Is that okay? So if S is finite, then we will get an increasing subsequence of xn. Is that okay?
Yes, ma'am.
Now suppose
Yes,
it
ma'am.
is infinite. Suppose. On the other hand, suppose S is infinite. If it is infinite, again it is set of subset of natural numbers.
Yes, ma'am.
Suppose S is infinite. So it is infinite subset of, that is S is an infinite subset of natural numbers, set of natural numbers. So by well ordering principle, there exists a list element. There exists list element in S, say n1. Are you getting this?
Yes, ma'am.
Yes, ma'am.
By well ordering principle, we can list them and we can have a list element, say n1. So if now let me, by well ordering principle, there exists list element in S, say n1. That is, n1 is less than small s for all s belongs to S. Now consider the set S minus n1. S मधून मी n1 काढून टाकलं. Then again this will be infinite set. Then S minus n1 is also infinite subset of set of natural numbers.
Yes, ma'am.
Yes.
Again we can use well ordering principle. So by well ordering principle, what will happen? There exists list element. There exists list element of S minus n1, say n2. We will denote it by n2. So what will be relation between n1 and n2? n1 and n2 मध्ये काय relation असेल?
N2 will be
One
greater
less than
than
n1 is less than n2 and they belongs to S. They belongs to n1 and n2 both belongs to S, right? So what is relation between xn1 and xn2? It will be greater,
Yes, ma'am.
right? Now again, now what I have to do? आता एक इलेमेंट एस मधून एक इलेमेंट काढला, मला दुसरा नॅचरल नंबर मिळाला. नाउ अगेन यू रिमूव्ह टू इलेमेंट्स, then you will get n3. Are you getting this? Again the set S minus n1 comma n2 is non-empty set because it is an infinite set, we are saying.
Yes, ma'am.
Then again by well ordering principle, then I am not writing again that well ordering principle, then there exists a natural number n3 belongs to n, n3 belongs to n, which is list element of S minus n1 comma n2. This implies, what this implies? n1 less than n2 less than n3 with
N3.
xn1 greater than xn2 greater than xn3. Is that right?
Yes,
Yes,
ma'am.
ma'am.
Yeah. So by repeating the same process, the above process, what I will, because it is an infinite set, so S minus I will remove infinitely many elements also, it will be non-empty, and for every set since it is infinite subset of natural numbers, there exists list element and we will denote it as n1, n2, n3, n4, n5 and so on. Okay, so by repeating the process we get n1 less than n2 less than n3 less than n4, so on, with xn1 greater than xn2 greater than xn3 greater than xn4, and so on. So I will get a decreasing subsequence, which
Yes,
is
ma'am.
decreasing,
Yes, ma'am.
Yes, ma'am.
which is decreasing subsequence of
Excellent.
xn. So in either case, we are getting either increasing sequence or sequence you say, or subsequence, okay, of xn. So whenever I am having a sequence of real numbers, we will have a either decreasing sequence or increasing sequence, means every that is every sequence of real numbers has a monotone subsequence. Is that okay?
Yes,
Yes,
ma'am.
ma'am.
Yes. So now, mm, now we state Bolzano-Weiestrass theorem. Bolzano-Weiestrass theorem. What this theorem says, that every bounded sequence of real numbers has a convergent subsequence. Has a convergent subsequence. What is extra here? What is difference between earlier theorem we have proved and this Bolzano-Weiestrass theorem? Earlier we have proved every sequence of real numbers has a monotone subsequence, and now we have to prove, suppose it is moreover bounded. Moreover, suppose it is bounded sequence of real numbers, then instead of monotone we will get a convergent subsequence. Is that okay?
Yes, ma'am.
Statement.
Yes, ma'am.
So many times this can be asked as state and prove Bolzano-Weiestrass theorem. Okay, so whichever theorems has name, they can be asked as state and prove theorem. So you have to remember statement also and proof also. So can you tell me the proof now? Already we have proved 90% of it. So let xn be a bounded sequence. Let xn be a bounded sequence of real numbers. Then what can I say? Then it will have a monotone subsequence. Am I right?
Yes, ma'am. Yes, ma'am.
Then by above theorem, it will have a, means again we can write the proof of that same theorem. Let us we define that set S is finite. If S is finite, we will get increasing sequence. If S is infinite, we will get a decreasing sequence. Okay. So we will get a monotone subsequence. Now I want to prove that monotone subsequence is convergent subsequence. Is it right?
Yes, ma'am.
So how can I say it is convergent subsequence?
If we prove it is,
Then
if
by above theorem, it has a monotone subsequence, say x and k. Now it is that is bounded. What is that? That sequence is bounded. Xn is bounded.
yes, ma'am. So it will have an upper bound.
So xnk is also bounded sequence. Xnk is also bounded sequence.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Suppose xnk is an increasing sequence. As xn is bounded, xnk is also bounded. Xnk is also bounded.
Yes, ma'am.
Yes, ma'am.
So if it is bounded and increasing sequence, what can I say? It will converge to its supremum. Already we have proved.
Yes, ma'am.
Therefore, x and k will converge to its supremum. To its supremum. Right? But we already proved, na? Bounded and increasing sequence will converge to its supremum. This already proved. And if it is if x and k is decreasing,
Then it will converge to its infinity.
decreasing sequence, then also xn is decreasing and decreasing sequence. Okay, I will write. Which is bounded also, which is then x and k will converge to its infimum. This also we have proved.
Yes, ma'am.
So in either case, that monotone subsequence will converge. So x and k is a convergent subsequence. That is, in any case, x and k is a convergent subsequence of xn, and which proves the theorem. Is it right? Is it right? Are you getting the
Yes,
proof?
ma'am.
Yes.
So,
Yes, ma'am.
so if it is asked for 8 marks, then you have to write the proof of that theorem also. So you have to start with x and be a bounded sequence of real numbers, and then you have to write the proof of this theorem. Whatever I have already proved here. Is that okay? And then
Yes, ma'am.
this also we have proved. If it is an increasing sequence of increasing bounded sequence, then it will converge to its supremum. That also we have proved in earlier theorems. That proof also you have to write. And using supremum, you can easily prove decreasing sequence that it will converge to its infimum. Is that okay?
Yes, ma'am.
Yes, ma'am.
Okay. If it has been asked for 5 marks, then this much is enough. Means you can directly say that by the above theorem, instead of above theorem, you have to write the statement Since every sequence of real numbers has a monotone sequence, there exists a monotone subsequence, there exists subsequence x and k. Suppose it is increasing. Okay, and then you can write these things. Is that okay?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay, so now lemma. If xn converges to x and xnk be a subsequence of xn. Then xnk also converges to x. Means if x is the limit of original sequence xn, then that x will serve as a limit of its subsequence also. Is that okay? Can you prove this? How can I prove this? Are you there, students?
Yes, ma'am.
Yes. How can I prove this? Suppose or given xn converges to x. Given xn converges to x. Let epsilon greater than. I want to prove my claim is xnk converges to x. So start with epsilon greater than 0. Okay. So let epsilon greater than 0. So for this epsilon greater than 0, what will happen? There exists, then there exists natural number, say p belongs to set of natural numbers such that mod of xn minus x less than epsilon for all n greater than or equal to p by definition of convergence. Is that okay? Yes. Now I want to prove for this epsilon greater than 0, I want to find a natural number such that mod of x and k minus x is less than epsilon for all nk or for all k greater than or equal to nk greater than or equal to that natural number, whatever may be that natural number. Nk usually nk is greater than or equal to k and 0 I will see. Is that okay? So let
Ma'am, can we take x and k, which is subsequent? So we can take x and k is less than xn.
xn k is less than xn.
Okay. Which is
So let k greater than or equal to p. Then nk, what can I say about nk? Nk is always greater than or equal to k and k is greater than or equal to p. Now consider, so what can I say? Then what can I say about x and k minus x? X and k minus x. What can I say about this then? Whatever you are saying, the same thing here, na? Is less than epsilon for as nk is greater than or equal to p nk is greater than equal to p, because we are having this, and whenever n greater than equal to p, xn minus x is less than epsilon. Now here this nk is greater than equal to p, so I can say mod of xnk minus x is also less than epsilon. Is that okay?
Yes, ma'am.
And this implies mod of xnk minus x is less than epsilon for all k greater than equal to p. So this implies xnk also converges to this x. Is that okay?
Yes, ma'am.
Yes, ma'am.
Yes, sir.
Now we, okay, that Cauchy sequence, and that we will define in new lecture. I think Reddy sir, when Reddy sir is going to take? I think afternoon. Whether Reddy sir inform you the timing? Okay, so today we can stop here. Any doubts?